We are going to solve systems of linear equations by elimination. This should feel like review, but here we go. So we got three levels of it, or at least what I'm going to call three levels of it. In the first level, it's pretty easy. What you do is you look and you go, hey, wait, if I add or subtract the top from the bottom, will one of my sets of variables disappear? And the answer is yes. Well, if I take the top one and subtract the bottom one, the y's will go away. So I am going to subtract the whole bottom from the top. So this is 3x minus negative 4x. Well, that's going to give us an answer of positive 7x. 2y minus 2y is going to give us 0y. Most of the time we won't write that. 5 minus 7 is negative 2. So now I've got an equation with only x's in it. That's eliminated. So we get x is negative 2 over 7. And then what we need to do is take this and plug it back into either equation to get the other variable. We've done that many times, so I'm going to move on. So level 2, this red one here, we have what I asked before is, can we add or subtract these from each other and then get rid of one of the variables? And 2 minus 5, no, because my coefficients aren't the same, there's nothing I can do. So then I got to ask myself a different question. Can I multiply the top equation or the bottom equation by something to make this true that we had from over here? And 2 times some number equals 5, that's not fun. 5 times something equals 2. Again, not fun, right? We could multiply by 2/5, but that's no good. But look at this. If I multiply this negative 7 by 2, I'll get 14. That'll be good. So I'm going to take this whole top equation, and I'm going to multiply it by 2. And I'm going to just, as I multiply it, I'm going to bring it down here just so that we can see what's happening. So I'm going to distribute this 2 all the way across. So 2 times 2x is 4x. 2 times negative 7y is negative 14y. That was the reason why we chose 2. And then 2 times 5 is 10. Now I can see if I add this equation to this equation, the y's will disappear. So if I add them together, I'll get 9x, 5 and 4. These will cancel out. 0y is 18. Now I divide both sides by 9. I get x is 2. So the interesting thing here is we've got the x, we need to get the y. The interesting thing is we can plug into this equation, or even this equation if we really wanted to. It's usually best to choose one of the two equations that were given to you, but we could go into any of them. It doesn't matter. Okay, last one. Level 3. So what I said is, if I add and subtract them, will I eliminate a variable? And the answer is no. So that means I need to multiply something, right? That's what we did in this red one. So is there any number 2 times 3, 2 times some number equals 3? No. 3 to get to 2? Nope. 5 to get to 4? Nope. 4 to get to 5? Nope. So we've got a couple options of what we could do. I'm going to choose to make both of these 6x. And the way I'm going to make both of these equations start with a 6x is I'm going to take the top equation and multiply it by 3 because that's what this is, right? It's like finding a common denominator. And I'm going to do the same thing with my bottom equation. I'm going to multiply that by 2. So I'm going to rewrite these equations. I'll do this first one right here. So 3 times 2x is 6x. 3 times 5y is 15y. 3 times negative 7 is negative 21. And I do it again on the bottom. 2 times 3 is 6x. 2 times negative 4y is negative 8y. 2 times 5 is 10. And now, what's that one? Now I can look at that and go, oh, look, if I subtract these equations, just like I did over here, I should be able to eliminate my x's. So 6x minus 6x is 0. 15y minus negative 8y. 15y minus negative 8y is 23y. And then we have negative 21 minus 10 is negative 31. Right? So the division isn't going to work out nicely. I divide both sides by 23. I get negative 31 over 23 is my y. Now I need to go back and get my x. I plug this number into this equation, this equation, this equation, or that equation, and I'll get the right x. And that's it.